Next, we're going to look at some problems that involve calculating or estimating an area. And we're going to look at those in different contexts. We're going to look at some different examples from the AP exam where these concepts have come in. And here's the first example. The fact that when we have a rate graph, okay, so in this case is a rate graph where I have barrels per hour on the y-axis and hours on the x-axis. So the area under this curve, if I just use one little square of it here, if I'm talking about calculating the area under this barrels per hour curve, when I take barrels per hour times hour, so barrels per hour times an amount of hours, that result is going to be a number of barrels. So this question about total number of barrels is in fact an area question. It's a question that's asking us to estimate that particular area, which we don't have a name for this function, but if we did, we could say we're going to do the 0 to 24 integral for f of x dx if f of x was the barrels per hour function. Now, as I look at these areas, looks like one square on this grid is 6 by 100, so that's a 600 barrel square. I've got 4 of those, so that's 2,400, and I have more than that, so 2,400 is not enough. 600 is too little. What I have up here looks like approximately half of a rectangle, so probably another 600, 300 on each side. So best answer for that problem is B. Example 8. I'm given a graph. I'm asked to calculate the area, the integral from -1 to 4 of f of x dx. So that's going to be the area starting at -1, ending at 4, between the x-axis and this function curve. So that's going to count positive because it's above the x-axis as I go left to right. This little piece is going to count as negative. So when I look at this positive part, I see a trapezoid that is 1, 2, 3 units across one base and 1 unit across the second base. And if I take some of my drawing out of here, you can see there's 3 units, that's 1 unit. So a half times the sum of the bases times a height of 2. It's like this is an area 4. My little guy here, my negative guy, I've got a half. His bases look like they're 1 and 2. And his vertical height is 1. So that's going to be 3 halves. So positive 4 and negative 3 halves is positive 5 halves, or 2.5. Now, this next problem is going to bring in the idea of going backward. This is where we're going to have a couple different ways to talk about this. So the first one says find f of 5, big F of 5, given big F of x is the integral from -1 to x of little f. And this graph is the little f graph. So big F of 5 is going to be the integral from -1 to 5 of my little f graph. Actually, I'm going to do this before I write too much on this. I always forget. Where are you, screen capture toolbar? Here you are. Let me grab this guy. Send him to a new page. I'll deal with him in a minute. Okay. So we're going to go from -1 to 5. This is my start. This is my end. I'm going that way. So here's my x-axis. Here's my one boundary. That's going to be positive. That's going to be negative. Now, if I get rid of that for a second so I can see what's going on, it looks like the positive part is a triangle. Okay, so going from here to here is a triangle with a base of 2 and a height of 4. Negative part, it's telling us is a semicircle, so half a circle. So pi, if this is half of a circle, that would be the center of the circle. So pi r squared divided by 2. So the positive piece, the negative piece. So my area is 4 plus, actually, I lied. It's not 4 plus, it's 4 minus 2 pi. 4 minus 2 pi. This little piece is 4, and this little piece is 2 pi. And this is my start, and this is my end. If I'm asked to do f of -5, that's going to be the integral from -1 to -5. Of f of t dt. Right, so this is where I'm going to go on my new page. So I have this guy to work with. All right, so here he is. Little furry. But we're going to do an integral from -1 to -5 of f of t dt. So that means I'm going to start here, and I'm going to end here. So I would consider this backwards. Forwards is left to right. If I'm starting and then moving to the left from a starting point, I'm going backwards in the context of these area problems. So there are two different approaches to this. One of them, and this will, for some of you, will be your favorite way, is you're like, okay, yep, I don't do backwards, I go forwards. So I'm going to start here, and I'm going to end here, and I'm going to do all the area calculation. But my final answer, I'm going to take the opposite, because it really was a question where it wanted me to go from -1 to -5. It really wanted me to kind of go in reverse, go in the backward direction. So I can calculate it like normal, but then I'll make the opposite happen. So a big old opposite. And then this guy is negative, and that guy is positive. So I'm going to have the negative triangle, which will be 1/2 times 2 times 4, plus, we're going to actually stop right there, so plus a positive trapezoid, which will be 1/2, 1 plus 2 times 4. So this is going to be a big old negative here. -4 plus 6 so my final answer is going to be -2. This piece is bigger than this piece. This is 1, 2, 3 whole squares, and then 3 pieces. One of these pieces is almost a whole, so maybe 1, 2, 3, 4, almost 5. And then this is 1, 2, maybe 3 whole squares. There's definitely more area in the trapezoid than the triangle. They're close, but there's more here than here. So normally when I put these together, I would get a positive area, but I'm going backwards. If I'm going from -1 to -5 in the original problem, I'm going to get the opposite of the forward answer. That is going to take some time to think about. And you may actually have to go through this a couple times. You may have to talk to us in person about this before you're feeling really good about this whole backward thing. If you're trying to figure out kind of like, well, why was she saying it's backward? What's the, meaning of that? Couple ways you can think about that. I'm trying to add another page in here. Here we go. Okay. One of the things is usually when we write an integral, a is smaller than b. So if I write an integral that has a 7 here and a 3 here, where this is normal, in this case, my a is 7, my b is 3, 7 is bigger than 3. That makes me feel like this one is sort of a backwards problem. And so I can adjust that by treating it as forwards and then throwing the negative in front of it. When we're actually looking at a graph, let me throw another piece in here. Okay. If I've got, let's say I've got something like this, and we'll call this will be A, and this will be B. And we'll say this is 0, and we'll say this is 5. If I write, and this is my f of x curve, that green thing. If the integral looks like this, that means this is, oops, I don't need to label them. So let's say that this is 0, and this is 5. And that's the integral I want you to do. So that means I'm considering this the starting point and this is the ending point. And so I'm going to think backwards about this one. And so the best way to do that is go, well, it's going to be the opposite of what I would get from 0 to 5. Okay, if I'm going from 0 to 5, this would be positive and this would be negative. I have a lot of different arrows on here. So the normal way to think would be this would count as positive and this would count as negative, and I would calculate that, the combination of those areas, but then take the opposite of it. We are going to practice this a lot. I know that this is probably one of our least favorite things to talk about right now, is this whole forwards versus backwards. And in the signed area context, it's going to be important that we pay attention to that. So looking at how A and B relate to each other to figure out if what we're looking at is forward or backward will be important. We will have techniques later where we can deal with it either way, and we'll be able to get our answer either way. But for now, when we're using a graph, it's going to be very important starting and ending, starting at A and ending at B, and thinking about how those areas are going to represent signed values.